instantaneous velocity is defined as? Instantaneous, it means at some moment of time, and it is defined as a rate of change of the position of a particle, or the rate of change of displacement, or if it's a one-dimensional motion, we can say that it's the rate of change of coordinate of a particle. And rate of change, it's a derivative, and from a graph it's a gradient of a tangent at some moment of time. And velocity, it's a vector quantity. It has a value, magnitude, and direction. Speed, it's magnitude of velocity. It's a scalar quantity. It has magnitude oddly. And velocity is related to displacement or position vector or coordinate if it's one-dimensional motion, and speed is related to distance. And instantaneous speed, it's the rate of change of distance. And what is displacement over time taken? Displacement, its vector quantity, is related to velocity, so it's average velocity, and total distance traveled over total time, it's average speed. The next, the variation with time t of the acceleration a of an object is shown. At t0 the object is at rest. What is the speed of the object when t is 8 seconds? Speed, it's a magnitude of velocity, and we know that when acceleration is constant, the final velocity is the initial velocity plus acceleration multiplied by time. These values may be positive, negative, except time, it's always positive. But when acceleration is not constant, this at becomes area. And area, it's integral in general, but integral is not required. We need area from acceleration time graph, and it's area under the curve and t-axis. And also you should take into account that when curve is above t-axis, area is positive. It's the same as integral is positive when the curve is above x-axis, and when curve is below x-axis, integral is negative. And so when this curve would be below t-axis, this area should be taken as negative to find the total area, because the total area gives us change in velocity, not the final velocity, but change in velocity. It's an equivalent of this at when acceleration is constant. So here the final velocity is 0. The initial velocity is 0 because it starts from rest, and area, you can see that the curve is above the t-axis, so this area should be taken as positive, and the area is, and we need from t0 to t is 8, so the area from 0 to 8 seconds should be considered, and the area is what, just half times base times height, and it's half times 8 times 8, and it's just 32, so change in velocity is plus 32. Hence the final velocity is 32, and by magnitude the final speed is also 32. So B is correct, and that's all for this question.